All right, so let's look at number 1 here. Now, that 3 times 3 to the second, that would be 3 to the first, we could say. So we could just say that this then is, 3 to the third. That's a really bad 3. 3 to the third power. Okay, and we're not, on these, I don't want you to evaluate it if it's just numbers, so that'll be 3 to the third. I do understand it's 27, but it's no big deal. 4 to the third, so just multiplying the power, so it'd be 4 to the ninth. If we go over here to number 3, that should just be 2 to the first, or just 2. Here, let's go ahead and combine the powers on the inside, so it's 2 times 2 to the fifth to the fourth. So then I have 2 times 2 to the 20th, which that's still 2 to the first, so this is 2 to the 21st power. Number 5, distributing that power, we should have 2 to the negative 8th times 2 to the third, so I get 2 to the negative 5th power, so I'll change that to a fraction, 1 over 2 to the 5th. All right, now number 6, the numbers now I'll start to multiply, so I see that I have a 4 and a 2, so I'm going to say that that is 8. And then I have a x to the third and an x to the fourth, so I'm going to say that that is x to the 7th. And last but not least, I have a y to the second and a y to the negative third, and that gives me y to the negative first. Well, to make that positive, I'll send it to the bottom, so it's over y, like that. Okay, let's move down here a little bit further. All right, number 7. Okay, 4 times 4, that's 16. X to the negative first, don't have anything that combines with that, so I'm going to send that to the bottom. And I have y and y to the negative first. Well, that's y to the 0, which is 1, so it just cancels. So there I go for number 7. Number 8, hey, everything's to the 0 power. Anything to the 0 power is 1, doesn't matter how many of those I've got. Okay, let's look here. I'm going to leave the 3 and the 8 to the 4th on bottom, because there's nothing I'm going to be able to do with that. But then I'm going to combine b to the negative 4th and negative 1. So I have to minus the negative 1, so it changes to plus plus. So I've got b to the negative third, so I'll just send that to the bottom as well. Okay. All right. Number 10. Hey, y to the 0 is 1, so it doesn't matter. Y to the 0 is also 1, so it doesn't matter. Now I'm going to combine everything inside, and then I'm going to raise it all to the power. So 2 doesn't change. That's a 2. Doesn't change. X to the second, x to the third is x to the 5th. All right? Yes. And we've got y to the 4th all over x. Right? I think I made a mistake earlier. Okay. And then we've got 2. Oh, that's all to the third. Now that's to the first power, so this is 2x to the 4th, y to the 4th, all to the third. And so we can say that this is 8x to the 12th, y to the 12th. And if we look at number 11 here, let's go with, 2u to the third on top there. For that, I'll send the v to the 4th to the bottom. And if I distribute this through, I get u to the negative second, v to the negative third. Now we'll just combine the powers. Those combine and these combine. So on top I end up with 2. U to the third minus a negative 2 is u to the 5th all over v to the 4th plus negative v to the third is v. All right. Okay, scientific notation real quick. 0.60 is 6 times 10 to the negative 2 power, and 60,000 is 6 times 10 to the 4th power. All right, number 14. It's 7,140. And this one is 0.00082. Not going to take the time to figure out what that is. Okay, now these here simplify. 7.7 times 5.3 comes out to 40.81, and then if we go times 10, combine the exponents, I get -3, but that's not in scientific notation, so we'll bump that forward. So I get 4.81 times 10 to the -2nd. Number 17, 7.5 or 7.5 divided by 3 is 2.5. Very nice. Times 10 to the -2nd power if we subtract the powers. Let's see now. If we go 9.8 to the 3rd, I get 941, I believe, times 10 to the -6, but I need to move the decimal 2 places to get 9.41 times 10 to the -4th power. Okay, and got to sketch some graphs here. So I'll do this pretty quickly. Making a real quick table here, x and y. We'll go 0. If I plug in a 0, I get a 1. If I plug in a 1, I get a 2. And if I plug in a 2, I'm going to go ahead and get a 4. And you know what? I'm going to go ahead and plug in 3. If I plug in a 3, I get an 8. Now, to make the inverse of the table, if I plug in a -1, that's a 1/2, and you can kind of see where I'm going. All right, now this will be kind of tricky to show. 0, 1 is right in there. 1, 2 is right there. 2, 4, 3, 8. And honestly, if I went to 4, I'd get 16, just to kind of go, you don't have to go that far, but just kind of get a general gist of the graph. And if I plug in a -1, I get a 1/2 unit, quarter, and so I get that for a graph there, okay? All right, 1/3. So, make a table. If I plug in a 0, I get a 1. If I plug in 1, I get a 1/3. If I plug in a 2, all right, so again, I get 1, so I'd get 1/3 squared, which is 1 squared, which is 1 over 9. And then if I plug in a 3, I'd get 1 over 27. So now just think, if you plug in the negatives of all those, -1, -2, and -3, you're going to get the same numbers, except for they're now not fractions. So they look like that. So I go from 0, 1 to 1, 1/3. Let's try that. It's kind of tricky to show. And then I go -1, I get a 3. Excuse me, I'm up there, not there. And -2, I get a 9. And 27 be way up here somewhere. So I get something like that. And there's our graph for that one. All right, so let's do number 21 here. Okay, so let's think about this, making the graph. Ooh, excuse me. Let's go to the pen. If I plug in a 0, I'm going to get 1/2 to the 0 power, which is 1 times 3 is 3. And if I plug in a 1, I get 1/2 times 3 is 3/2. Excuse me, 3/2. If I plug in a 2, I'm going to get 1/2 to the 2nd, which is 1/4, so I get 3/4. So then let's do -1. If I plug in a -1, 1/2 to the -1 is 2, so I'm going to get 6. And if I plug in a -2, I'm going to get 4. 1/2 to the -2 is 4, times 3 is 12, and if I did 8, I'd get 24, so I'll stop there. And so if I go 0, 3, -1 and 1, +1 is 3/2, which is 1.5, and then I get 3/4, and so you can kind of see we're dribbling, which is kind of the opposite of before again. Then if I plug in a -1, I get a 6, and if I plug in a -2, I get a 12. So here is my graph. Okay, let's do number 22. If I plug in a 0, I get 1 times 2 is 2. If I plug in a 1, I get 2 times 2 is 4. If I plug in a 2, I get 4 times 2 is 8. If I plug in a 3, I get 8 times 2 is 16. And if I did it the other way, I get -1, so I get a 1/2 times 1, or excuse me, half times 2 is 1, excuse me, 1 half times 2 is 1. If I plug in a negative 2, I would get 2 to the negative second is 1/4 times 2 is 1 half. So that's what I get. So 2, 0, or excuse me, 0, 2, sorry. 1 goes to 4, 2 goes to 8, and 3 goes to 16, which means 1 then goes, or excuse me, negative 1 goes to 1, negative 2 goes to a half, and looks like that. Okay, let's move down here to the last 4 problems. Okay, the value of a car is $25,000. The car depreciates, so that's a decay problem. So I'm going to have y equals 25,000 times 1 minus 0.11, because that's 11% is a decimal, and since it's a decay, I have to minus and find the approximate value in 8 years, so it would be like that. So it'll be 25,000 times 0.89 to the 8th. Make sure you raise 0.89 to the 8th first and then times it by 25,000. If we do that, we should get $9,841.47. Okay? Number 24, so you got a deposit of $1,250 in a savings account. Ooh, it's misspelled account. That earns 6.5% interest, so it's earning, so it's a growth problem, so same as before, except I'm going to add 0.065 and for 4 years. So it should be 1,250 times 1.065 to the 4th, and what I get there is $1,608.08. Okay, and let's go ahead and do the bottom ones here. Write an equation for the nth term. Okay, well, this is the first number of the sequence on 25 is 3, so I have to start with that. Now, it looks like we are multiplying by a negative 8, right? Because I go from a positive to a negative, back to a positive, and we want to find the 6th term, so that would be 6 minus 1 there, okay? And if we did that, we should get, well, that would be negative 8 to the 5th. We should get negative 98,304. Okay, I believe my sign is correct there. All right, and on number 26, a to the n, or a sub n, and we started at negative 96. Now, it looks like we are, what, dividing by 2 or timesing by a half. And we also want the 6th term, so it would be 6 minus 1, so it would be to the 5th. So 1 half to the 5th power times negative 36, or negative 96, sorry, gives me negative 3.